video on the estimation of technical efficiency. This time around, we'll be using data envelopment analysis, and we'll be making use of two packages: DEAR package for the estimation and DPLYR for our data manipulation. Like we did for the stochastic frontier analysis, I will be considering two types of data: cross-section data and panel data. For cross-section data, we'll still be using FDAT, which contains firm level data for 825 enterprises, small and medium enterprises in Nigeria. So let's quickly look at the data again. I've imported the data, so I don't want to go through the process of importing or setting our directory. Our directory is still TE training folder on my desktop. So say fix FDAT just to check the data again. So let's run. So this is our data sets. Remember, we have the size type, small and medium, the city, that's about 26 cities that were covered in the survey, industries, sales, labor, materials, and capital. So the first thing we need to do is to extract from the data sets those ones that we're going to use. So I have here that FDAT, percent greater percent, then select. We'll be considering industry, sales, labor, materials, and capital. We'll be using industrial as our decision-making unit, DMU. Then we have sales as our dependent variable, then labor, materials, capital as our independent, like before. So this is converting this DAT to data frame. It's just what I've done here. In order to estimate technical efficiency using DAR, we must first read the data into DAR format. DAR format. So we have it here, that one, read underscore data. What do you want to read? Our data. Then we define the DMU. So the DMU here, you say, is number 1. The inputs. Our input is labor, material, capital, which is column 3 to 5. That's 3, 4, 5. Then our output is sales, which is column 2. So these numbers represent the column where the variables are located. So immediately we define the data sets, then we are set for our estimation. So I call the result RES, then model underscore basic, then is the data sets. Orientation, the orientation can either be input output or output input. For input output, we have IO. Then our return to scale could be constant return to scale, decreasing return to scale, variable return to scale, and so on. So For illustration, I just pick a constant return to scale. Then after we have done that, then we get the summary. So let's run this from here up to the summary. That's okay. So, and in order to see our result clearly, we have to go to our working directory, which is TE training. This is the results, result DEA, you can see. So let's click on it so that we can see clearly the output. So here we are. This is the efficiency scores for all the 825 respondents. So you can see, you know, this is benchmarking. So those one with 1 are those on the efficiency frontier. So, and you can see others. So in terms of the slacks, these are the results. Then in terms of the targets, in terms of the returns, in terms of references. So all the results are here in Excel format, which makes it very beautiful in case you want to do some other things with the results. So let's close this. And let's come back to our R. So let us consider the case of panel data. In this case, we're going to be making use of a data set in DARF package called economy long. So let's see the content. So this is the data set in long form. So these are the decision-making units: Beijing, Tianjin, so on. So, and this is the period. So the period, we have 2006, 2005, 2007, 2008, 2009. So the period ranges between 2005 and 2009. Then we have our decision-making units here. Then we have the variables. So capital and labor will be our independent variable. Then GIOV will be our dependent variable. So let's close this. So in this case, we are going to read it as Malmquist because we want to estimate the Malmquist index. So we say read underscore Malmquist, economic long. So which column contains um, the period? This is Parcourt period column. If you look at the data set again, you will know it's column 2. It's column 2. This is the period, column 2. So the input is column 3 and 4, and the output is column 5. Then the DMU is column 1. So here we are, 2. Then the arrangement, this is in long form, so we call it vertical. Input 3, 4, output 5. Then to run it, say results. Now I put underscore M to indicate that we want to estimate the Malmquist index, which is a measure of the total factor productivity, so that we'll be able to look at the productivity changes over the years. So we have Malmquist underscore index as the command. Malm, that is our data set. Orientation, we're making use of input output, and this is the summary. So let's run this. Run. Yeah, so here we have the results. So again, the result will have been copied into our directory. So let's open the results here. Yeah. So here we have the results for all the respondents across all the years. And this is the Malmquist index, measuring total factor productivity. To calculate the productivity growth, you subtract this from 1. So this is about 17.8% growth. So this is efficiency change and technological change. Yeah. So very straightforward. And this is the mean for the period, as for the year. And in terms of for the DMU, so this just for the summary of the DMU. So we have 32 DMUs. So that is it. And again, I will send the manual for the DAR to us. Then for the theories, I think there's a book written by Tessin and Coeli, which will serve us, which will help us to understand the theory correctly, because everything I've just shown on here is the computation. This is just mechanical way of maybe trying to estimate. This just to teach us the estimation. But in order to understand the theory, the interpretation, I think you will need to go through the book. And again, I think I sent a book to us that is production and efficiency analysis using R. Yeah, I think it's focus on chapters 7 to 9. Yeah, is there too. So, and there are so many other very useful textbooks. So thank you very much. Like I said, please, if you have the time, go through this, then prepare your question so that you'll be able to listen to some of the questions you have. And it will be my joy if you have your own data and you apply um, just this approach. And you can maybe write a paper or put some of your students on a project so that you learn it the more. So thanks for giving me the time to share this knowledge with you. Thank you very much.